I'm going to talk today about C++ today. The beast is back. My name is Jon Kalb, and I wrote this book with Gaspar Asman. And the interesting thing about the book is that O'Reilly published this book. They gave Gaspar and I money to write this book. Not very much money, but they gave us money to write a book that they give away. You can download this as an ebook if you give them your email, and you can download this. So the question is, why would a company pay someone to write something and then turn around and give that away? And the reason, of course, is what you see right there. They want your email address. But why do they want your email address? The reason they want your email address is because they intend to publish more C++ books. This is their marketing. This is what O'Reilly does when there's a new technology. They pick some new technology, and they get a book out really quickly just to talk about the new technology, get people's appetite whetted, and then collect the marketing information that they will follow on with more in-depth books. This, when I call it a book, it's 60 pages. It's a booklet, let's be honest. But why is it that a language that was created possibly before some of you were even born is now a new technology? Well, that is really the subject of today's talk. And we're going to go back, and when I say we're going to go back, we're going to way back. Who can tell me what this is? I'm hearing mumbles, but I'm not. Yes, you got a hand up. What's that? The difference engine. And whose face is that? That's Charles Babbage, right. Now, this is not, of course, his difference engine. It's a replica made to that specification. And what is this? This is a machine he made so that he could calculate logarithmic tables or something like that. The information, those numbers, are stored in that machine. But also, the instructions for how to do that is essentially the machine itself. It's part of the machine. Very, very early machines, that's exactly, very early computing devices, that's how they were designed. But this man here, can you name? Von Neumann. He observed, he said, these computing machines, they operate on data. The instructions to run the machine is itself data. It should be possible that the instructions to run the machine should be part of the data of the machine. And so any machine that runs on programs that are in its own memory, as opposed to some kind of external force, we call that a von Neumann machine. And essentially all machines today are von Neumann machines. And when we talk then about storing the information in the computer, we think about everything in terms of numbers. So even when we store something that's not really a number in the computer, we do it by assigning a number to it, right? So whether it's a color or a character or a cat video, it's really just made up of numbers, right? So if we are going to put the program in the machine, what is the program then? The program is really just a bunch of numbers. But if we tried to think about software and instructions in terms of numbers, that doesn't work very well, right? So what do? We make up mnemonics. Who recognizes this set of mnemonics? What is this?
From the 6502.
That's a 6502, that's right. Someone here is writing in 6502 a code and then hand assembling this. So, and the reason for this is, of course, because as human beings, which programmers tend to be, it's hard for us to think in terms of instructions as numbers. So we have these mnemonics. We create a language. And we have this kind of incorrectly named thing called assembly language because it makes it sound like there's an assembly language. Of course, every platform has a different language, right? It's a different assembly language for the different platforms. But this is acceptable if you're a computing professional, that you're going to take the time to learn this really arcane platform-specific language in order to be able to squeeze all the features out of the machine, right? So if you're a computing professional, you can do this. But what if you're not a computing professional? What if let's say you're a scientist, and you don't really care about squeezing the ultimate out of the machine, you just want to use it as a tool to help you in your scientific work. So what do we do then? Well, this is where John Backus gives us Fortran, right? But what if you're a business person and you don't care about science, but you care about cranking numbers and maybe processing text, right? And so Grace Hopper gives us COBOL, right? Okay. So we actually had very, very early on this kind of divergence in languages to support business and support science. And we even had the same thing in the hardware world. So does anybody recognize this computer? Of course, this is not the whole computer. This is really just the control panel to the computer, right? You want to guess? It's a Univac. This is the Univac. This is the control panel, the Univac, right? So this came out in 1951, and it was for business and government, by which we mean that it's not for science. And it's going to process text, and it's going to have something called BCD, which means binary coded decimal, which means what? Which means we're going to put a decimal digit in a hex value. We're going to throw away much of the value of the range of our data, because if you're going to actually write in machine language, it makes just an awful lot easier to use decimal instead of hex. And so if you're going to write in business code, that's what makes sense, right? And then this machine, does anybody want to take a guess at this one? This is called a Link. It was the laboratory instrument computer, and in 1962, it was sold by DEC as a machine for laboratories. In other words, this is for scientists, right? So it didn't do text processing, it didn't do BCD. What it did instead was floating point numbers, right? That's what we need for this guy, right? So now we come up to the 1960s. In the 1960s, IBM did something very, very significant that cemented its lead in the computer industry. It was already dominant, it was already the leader, but this move made it the king in the computer industry, and that was this guy, the System 360. Those of you with really sharp eyes, you see that red button there? Do you know what that red button is? That's the stop button. That's because people heard about computers and they read these science fiction stories and watched these movies, and they were all, computers taking over the world. So if this computer got too uppity, boom, red button. Okay? All right. So I used to work for Boeing. And the reason it's significant is because I know what the 707 stands for. The first jumbo jet was a 707, Boeing 707. And I know what the 707 stands for because I worked at Boeing. And I learned that. Who knows what the 707 stands for? It stands for absolutely nothing. Some marketing guy said, this sounds cool. 707. It's kind of James Bondish and really, really sexy and modern and all sorts of stuff. So we'll call it the 707. So when I heard about the IBM 360, being this Boeing guy, of course I assumed, well, it doesn't actually mean anything. Somebody just thought 360 was a nice round number or something like that. But actually, the 360 means something. It has a specific meaning. Who knows what 360 means when they talked about the Boeing or the IBM 360? The full circle. That's really close. That's really close. That's what they meant. That's what they meant. The full circle. The marketing was that, I don't know if you can read this, but it says, now one computer fills all your data processing needs. And what did they mean by that? What they meant is, this machine does science and business. Both. All of it. Science and business. All the computing you ever need, science and business, right? What this meant was that they actually just, they put everything together. It does BCD, it does floating point, it actually does floating point BCD. I mean, it did everything, right? It had all of the instructions you expected of a science computer. It also had all the instructions you expected of a business computer. And it had something else, and I don't think this was the first to do this, I'm not sure. But it was so successful with it, it kind of established the idea that this is what we would do from now on. So it was designed to be the machine for science and business, featured BCD, hexadecimal floating point. The first instruction set implemented in microcode. The instruction set was so complicated because they just threw everything in, right? Everything was there. And it also did this 8-bit byte addressing. Now, that might not seem really radical to us. In fact, that's what we're used to, right? That's what a computer is, right? It's this machine to access bytes, and bytes are 8 bits, right? But that's not the way that computers were originally designed. There were all sorts of experiments. People did all sorts of things. 36-bit words, all sorts of different, really bizarre, bizarre ideas. Why would you have 36-bit words? What's the point of that? Why would you do that? Why would you have so many bits in a word? Why would you do that in one address? Why? It's to save on address lines, right? You're really trying to optimize your hardware, and if you have 36 bits in a word in a single address, then you don't have as many addresses, so you have fewer address lines. Right? But IBM didn't do that. What IBM said is, well, if we're going to have text, if we're going to support text, then we want to be able to address each individual character separately. Before, you would do these weird things, like if you needed to address the third character in the word, you would actually have a machine language address that says, load the word and then pull out the third character of that word. So it made things very complicated. But this 8-bit byte addressing, this is a win. In fact, it really established what we would call the C machine architecture a decade before C existed. So speaking of C, we're now in the 1970s. You can feel your hair getting longer, I can tell. And we're going to go here. Where's this? What? No. This is Bell Labs. This is New Jersey. This is Bell Labs, right? And Bell Labs had something, had the key ingredients necessary for the creation of Unix. It had these researchers like Ken Thompson and Dennis Ritchie, really smart guys. It had a need. It did a lot of, AT&T did a lot of document processing, and one of the things they really did was they filed a lot of patents. And how did you file a patent? Well, you had to make a really nice-looking document. And how did you make nice-looking documents? You didn't sit down and use Microsoft Word. What did you do? Well, you used a typesetter. You paid someone to typeset it, and this is very expensive. And so Ken Thompson and Dennis Ritchie, particularly Ken Thompson, said, I've working on this operating system thing, and I've kind of proven that it's useful, but if you'd get me a PDP a PDP 7 that I could write it on, then I will give you a document processing system. How many of you have used NROF? Anybody used NROF? Anybody know what NROF is? Somebody's got a hand up, right? This is the descendant of the original reason that Unix was created, was to do document processing, right? So what was Unix written in? What was the language that this operating system was written in? Who can tell me? Go ahead. Of course, C. No. C is the obvious thing, because we all know that Unix is written in C. But it was not originally written in C. It was written like every other operating system at the time. It was written in assembly language. Of course it was written in assembly language. It was rewritten in C when about, I think, Unix version 4, when they decided, well, we need to run this on more than just the PDP, right? We want to try other architectures. And we have a choice. We can either rewrite this whole operating system in assembly language again and again and again, or we could figure a way to rewrite it once in a portable assembler. And that's what C turned out to be. It was a portable assembler. And it turned out, remember when we were talking about these people who were, and I'm deliberately being somewhat condescending here because that was the way it was thought of at the time. These people who were not computing professionals, these people who just did business applications or just did science applications, well, they weren't real computers, And so they need to be protected from the arcane details of the machine. Well, it turned out that given the opportunity, computing professionals who were doing operating system software felt the same way. System software, they said, I would love it if you would handle the arcane details of the machine. I will write the code, you compile it in whatever the correct machine language is. So C took off. It was very popular, and it's recognized even today. There are some limits, though, and this is a little bit subjective, so if you disagree, we can talk about it later, perhaps. But C supports low-level abstractions very easily. Talk to the machine, talk to the hardware. It was designed for that. It does that very well. But when you start to get high-level applications, it starts to break down. Maybe, I've heard estimates like 50,000 lines of code. You got an app that's 50,000 lines of code. You start to want higher level abstractions than you have naturally in C. So now we're going to move up to the 80s. And now we've got to the 80s, we're now going to take a trip back. Because now we're going to talk about where C++ came from. And that requires that we go back. So usually I ask people who these people are, and nobody knows. But you guys know who these people are, right? Because you heard this morning about them winning the Turing Award for Simula, basically for the development of object-oriented programming and Simula, right? And it turned out particularly that that Kristen Nygaard was a faculty member at Bjarne Stroustrup's hometown, right? So when Bjarne went to get his graduate degree, he learned Simula. We all heard that story this morning. Then Bjarne, he goes off to college. He goes off to Churchill College in Cambridge, and he wants to write this research project. He needs to get information, and so he builds this simulation. And what did he build a simulation in? Simula, of course, because that's what he learned. That's how you do object-oriented programming. You write it in Simula. And he wrote it. He deployed it in order to get his data, and it brought the system to its knees. He didn't get any data before the administrator pulled the plug on it and said, you can't run this app. And I'm going to probably break a rule of presenting here because I'm going to show you a couple of pages of just text, and I'm just going to read it to you. It's worse. Couldn't possibly do worse. But I think it's really important, and so I want to stress this little story. And this is Bjarne speaking, saying, so I rewrote my simulator from Simula into BCPL. BCPL was a predecessor to C. I wrote my Simula into BCPL, and all of the high-level structures disappeared. All of the nice organization that had helped me debug and helped me design disappeared. But the resulting BCPL, once I had debugged it and lost half my hair in the process, ran really fast. It could use all of the resources of the machine. It could communicate with anything on the machine, and I got my data, and I got my PhD. I came away with the opinion that I would never again want to attack a problem with tools that were fundamentally unsuitable. And in particular, I don't want to make the choice between elegant, which Simula was for this problem, and efficient, which BCPL was. I want both. And that has been sort of one of my guiding lights. If you give people the choice of writing good code or fast code, there's something wrong. Good code should be fast. So this, as Bjarne said this morning, this has been one of the important guiding lights for the development of C++. So Bjarne gets hired at Bell Labs, and of course Bell Labs is this institution that was very much about Unix and C. So when he decides that he's going to build a tool that has the performance of BCPL, of course he's going to base it on C. And so we have this superset of C. And he was asked about this, and I want to repeat the question and his answer because I think there's a lot of information about the way C++ programmers think. The question was, did he regret basing C++ on C? And the reason to ask the question is there's an awful lot of baggage in C++, and a lot of it goes back to that C syntax, right? By basing it on C, you inherit all the baggage. In fact, I think Bjarne told us this morning that even Dennis Ritchie thought that the declaration syntax in C was probably not well designed. And I think I agree. I hope some of you would agree. But Bjarne's response to this was, he said, no. He said, because if I didn't build it on C, I would have built it on something else. And I think what I get from that is that given a choice between picking something that has a proven record of usefulness and a theoretically pure fresh start, the C++ programmer takes something that works, maybe not beautifully, but works, has proven itself, established a track record, and based on that. So if you want the theoretically pure language, you probably don't want to be working in C++. If you want a practical language that's going to get you somewhere with a proven track record, that's what attracts people to C++. So during the 1980s, the number of C++ programmers doubled every 7.5 months. And I want to take just a minute and talk about why are people attracted to C++? Why was that happening in the 80s? What was causing that? And for those of you who are keeping track at home, this is now we're finally at chapter 1 of my book. And the question is, why C++? I'm not going to read you all these slides of text, but the key point is high-level abstractions at low cost. And you can talk about, we could spend time mentioning all these, but these are high-level high-level abstracts at low cost, but the one I do want to talk about is the first one, user-defined types. And the reason is because in C++, this is how we solve a problem. We create a new user-defined type. That's what we do. That's how you solve a problem. You have a problem, create a new user-defined type. It may be a template, it may be whatever, but that's how we solve problems. And because that is our go-to, the overhead of that abstraction has to be really, really low. And as Bjorn said this morning, we just concatenate things together, right? Here's a thing, there's no overhead to that, right? But in C++, because of our ability to overload operators and things like that, we can make these user-defined types have the power and expressiveness of built-in types, or very close to that. Almost anything that can be done with a fundamental type can be done with a user-defined type. And in fact, we can, by creating these user-defined types, we can emulate built-in types with almost, not quite, but almost the same kind of efficiency you have at a built-in type, right? We make smart pointers that have very low overhead compared to real pointers, natural pointers, and function pointers, object pointers, all these kinds of things that we can create ourselves. These high-level abstractions are not forced on the user. There's a number of different paradigms that are supported in C++, and it's up to you as a user to pick and choose what you want to do and how you want to combine them. And they are, in fact, designed to be combined, to be usable in that way. You freely mix these. I think of C++ as a language for creating libraries that are very efficient and highly usable. And that's the way I think of C++. There's lots of stuff in C++ that most people don't need to use on a day-in, day-out basis. Why? It's because some library writer, some guy working on some boost code, needed to understand metaprogramming at a level that I hope to never have to understand, but I'm going to use that library and I'm going to have that benefit, right? So we get, power, efficiency, safety, natural syntax, all these kinds of things from libraries. If we have the need, we can create that library ourselves. If not, we can reuse someone else's library. And of course, little or no abstraction penalty. What Bjarne said several times this morning is the zero overhead principle, which means if you don't use the feature, you don't pay anything at all. And if you do use the feature, what you're going to pay is not going to be any higher than if you were to write it yourself. Right? I mean, I always think when I think of this, I always think of virtual functions. There's an overhead with virtual functions. But if you really need that kind of polymorphic behavior, you could write, in fact, people in C all the time are reinventing virtual functions, right? But you're not going to make it any more efficient than the C++ compiler can do it. Low-level access when you need it. We don't really need to dwell on this. It's based on a portable assembler. So, of course, everything that you can do in portable assembler, you can do in C++. That came free by this decision that Bjarne made very early on to base on C, paying the price of inheriting the baggage that he inherited, but that was the price he paid, right? So we now have this low-level access. There's one example I want to pull out, and that is something, again, that Bjarne kind of touched on this morning. In most object-oriented languages, you have some way of saying, I need to create this object. And so what happens? We allocate something from the free store. Something comes from the heap, and then we run some kind of initialization on it to zero it out or set the original data, whatever we want to do, right? And of course, we can do that in C++. C++ supports object-oriented programming, just like any other object-oriented programming language. You can do that. But the difference is that in C++, what if you didn't want to put it on the heap? Well, in most other languages, you can put it on the heap or you can put it on the heap. You have that choice, right? Or you could not do anything at all. But in C++, if you wanted to put it on the stack, you can do that. And why would we want to put it on the stack? Well, it's a trade-off. We have less control over the lifetime of the object, right? Function goes out of scope, the object is gone. However, the performance difference of putting something on the stack versus doing a free store call and then a subsequent free store call to delete it is huge, right? So, and who's going to make that decision? Well, you're going to make that decision as the programmer. There are going to be times when you say, no, I need a long lifetime that I can manage. It's going on the heap. There are other times, no, I need a temporary object. It's going on the stack. And you make that call. You make that decision. So that's what you might expect of C++, but actually C++ goes beyond that. C++ says, well, you might want to put it in a static location. You might want it to be global to the program. Well, we can do that. But we can even go further. And that is that with C++, you can take an arbitrary chunk of memory and say, I want to call the constructor in place in this arbitrary chunk of memory, and I will control the lifetime of this arbitrary chunk of memory and also the objects that are in it. That's how the vector class works, right? Vector class originally starts out with uninitialized memory, and every time you do a pushback, a copy constructor is called in place to create the items, right? And the vector manages the lifetime of the object. That's the kind of power we expect with C++. The restriction that, oh, you created an object-oriented object, you're going to have to put it on the free store, that's completely unacceptable in the way we approach things in C++. We also have other kinds of things like we can do cache optimization and worry about fault sharing, things like this. Most languages don't worry about those kinds of problems. Why not? Is it because they don't happen in other languages? No, it's because they couldn't do anything about it. You can't control how objects are laid out or where they are in memory. You just don't have that level of control, so you don't worry about those kinds of things. But in C++, not only do you have those kinds of control, one of the things that you can do is you can say, I want my container objects to put things in contiguous memory. I don't want to have just managing a bunch of pointers into the heap. I want my objects in contiguous memory because that's really nice for caching, really nice for look-aheads. Right? There's other reasons for C++ that people were attracted to, and one is this wide range of scale. We're software engineers. The question we always ask is, does it scale? Well, sure, you wrote it, it handles 3 pieces of information, fine, but does it scale? Can we do 3 million pieces of information or 300 million pieces of information? Does it scale? Well, C++, yes, scales both up, can handle very large applications, but also scales down. It has a low footprint. This zero abstraction means that if you're not using a feature, you don't need the memory for it. And so we can scale both up and scale down. And of course, because it's designed from portable assembler, that means it's highly portable. There's lots and lots of platforms that will support anything that supports the C machine, which, because of the popularity of C, that's what hardware makers make. They're going to make machines that work well with C, and so that means they work well with C++. But there's something that's outside the nature of the language. Suppose I came to you and I said, hey, I've got this new language for you. I've invented a new language. It has the syntax, it's like butter. It's beautiful. It is pure. You will understand it. You will love working with it. And the semantic it solves problems for you. It's just wonderful. You say, oh, wow, that's great. Could we actually think about using it? It's like, well, there's a few things. You know, it doesn't really have good compiler support. You can't really buy any books or hire anybody to train you how to use it. It doesn't really support many platforms. There's all sorts of things outside the language that affect whether or not a language is a good choice. And those decisions tend to work very strongly in C++'s favor. The industry buy-in in C++ means that there's good platform and there's good tooling support and there's lots and lots of information, some of it even accurate, about how to use C++. This large installed base works very much to C++'s favor. And I'm not going to say, while I'm up here, I'm not going to say anything bad about any other language except, of course, Java. But I'm not going to say anything bad about Rust or Go or Dart or any of the other languages. They're all kind of part of what we'll go into, talking about why C++ is getting so much attention now. It's because system software is so important now. And so other languages are being created. And the difference between, from my point of view, between C++ and the other languages, I mean, you can argue about the syntax and the intent and all this kind of stuff, but the biggest difference is this installed base. The industry has bought in to C++. Will that always be the case? Am I saying these other languages don't have no chance? I'm not saying that. What I'm saying is, looked at from today, if you're going to put together a team of engineers and you're going to deliver real software in 6 months or 2 months or whatever your management thinks is reasonable, you're going to be faced with trying to make some real hard decisions. And being able to use C++ with the tooling support, the industry buy-in, the fact that you can hire people who already know how to use C++, you're not going to have to teach them some new language. These are all advantages. When I say hire people, I'm assuming you can hire people. That's kind of one of the issues we're faced with. One of the things that C++ also offers is kind of better resource management. A lot of languages, particularly when you look at object-oriented languages, rely on garbage collection. And garbage collection is a really important solution to a really difficult problem. I don't know, because of the lighting in here, I don't know if you guys can notice it, but I actually have some gray hair. Every one of these gray hairs, that's a memory leak, right? Or a double dispose that I had to track down. So when somebody comes up and says, hey, I've got a solution, solves all your problems, it's called garbage collection, that's very attractive to me, right? But it's a solution. It's an engineering solution. And every engineering solution has some pros and some cons. So what are the cons of garbage collection? Well, there are some problems with it. If you want your memory released, it may be released at some arbitrary time in the future. That's maybe not quite as important. We'll see that where memory is concerned, but other resources may have issues there. You may also be garbage collecting not under the control of the programmer. Again, this may depend on the language you're using, but you may have the situation where the app you're running suddenly kind of freezes while garbage collection is going on. And that may not happen at a time when that works for you. You may also have a situation where in order to practically use an application, you have to have a lot more memory than what the application is actually using in order for the memory manager, the garbage collector, to work efficiently and effectively. So in C++, we have to have a better solution. And it needs to generalize. It needs to be able to handle things other than just memory. Remember, Bjarne this morning said, I don't like to solve the problem in front of me. I want to solve the general class of problems. And handling resources is a general class of problems, of which memory is probably the most, the one that we deal with most, right? That's the resource that we're just going to handle over and over and over again. But we also need to handle other kinds of resources. The operating system may provide us with file systems or mutexes, or we may have database connections. And all of these things might be constrained in some way, and we have to manage them properly. So in C++, we leverage deterministic destruction, which is a very, very important language feature. Perhaps the most important language feature. Arguably, the most important character in C++ is the closing brace, right? Bjarne came up with the term RAII. Bjarne is a really kind of a, Alex Stepanov says he's the greatest language designer of his age. But he doesn't really market well, and he doesn't know a good acronym when it falls on him. And RAII is not a good acronym, and you can just ask him. He's the first one to say that's why I feel free to say it, as Bjarne always says that about it. It's supposed to stand for resource acquisition as initialization. I think a better name is responsibility acquisition, because there are things that we want to manage. Like, for example, suppose I'm writing a GUI app, and I'm writing an object, and this object is going to draw something. And the first thing it needs to do is it needs to change the foreground color. And this object needs to restore the foreground color before it returns. Otherwise, it's not playing, it's not a good citizen, right? And if we add an early return or something like that, so we accidentally don't restore the foreground color, we have a problem. The foreground color is not a resource. The ability to set the foreground color, you could think of it as a resource, but setting the foreground color, that's not a resource. And yet, it needs to be managed just like a resource. And so the way we manage that is to create this RAI object, which, when it's created, acquires the correct setting, and then you make whatever changes you want, and then when it goes out of scope, it restores the setting, right? So that's the RAI approach. And it works just as well with resources as it does for any other kind of responsibility. When I used to teach C++, my students, if they felt there was a quiz coming on and they wanted to distract me, they would ask me, well, what do you think of Java? Thinking that was going to bait me. And I would always answer very quickly and say, I know nothing about Java. I couldn't possibly program in Java. I don't know how to program in any language that doesn't have destructors. And I really mean that in a very clean way. I don't know how to, as soon as I do anything, I'm connecting to the database. I'm changing the foreground color. I put something on the stack immediately which discharges that responsibility for me. That's how I write code. I wouldn't know how to write code in a language that didn't do that. Some languages have this, this finally, but really, finally violates DRY. What's DRY? What's that? What? Usually in America, I can get at least 3. Yes, don't repeat yourself. So, but why does finally violate this don't repeat yourself? Well, the solution to a resource-freeing situation in C++ is to create the RAI object. We create it once, and every time we use it, it's going to clean itself up. But if every time I use the object, I had to write a finally clause, that's looking for a maintenance problem, right? I mean, there's going to be some time when someone uses it and forgets to do the cleanup, or through maintenance something happens, and we don't want to do that. We want to write this once and only once. Michael Case. Do you ever notice how Michael's name doesn't get mentioned enough in conferences? Okay, so we're now at the 1990s. And some of you might actually be old enough to remember the 1990s. But if you were, what you'll remember, the most important thing about the 1990s is what was really, really popular in the 1990s. Object-oriented programming. This is the object-oriented, this is the decade of object-oriented programming. It was going to solve all our problems in software because it was going to allow us to do reuse. We're going to be able to create objects and reuse those objects. Now, you might tell from my tone of voice that I think it might be a little overhyped. Object-oriented programming might not be the solution to everything, but in the 1990s, it was the solution for everything. Particularly, there is one area I think object-oriented programming works really well, and that is solving GUIs. GUI frameworks really map well to object-oriented programming. And this was the 1990s, right? This is when Windows and the Mac were hot and battling it out, and so, of course, GUIs were very interesting at the time. Something else happened in the 1990s, and that is some large companies approached Bjarne and said, you know, there's a lot of people who are starting to use. Remember I told you in the 80s, the number of C++ programmers were doubling every 7.5 months. So there were starting to be a lot of C++ programmers, and there were a lot of companies, important companies that had substantial investment in C++. And so these companies went to Bjarne and said, you know, we have a lot invested in this language, and we probably don't want to have all of that investment kind of in the hands of some one guy. We need to make this an international standard. And Bjarne admits he was a little hesitant to let loose, but he did. In fact, he gave the text to the development and evolution, is that right? Development and evolution of C++, the book. He gave the text to the standards committee. He said you could reuse any text in here you'd like. He was very supportive, and of course he's been active in the standards committee ever since then. But the fact that this was starting to standardize was very important milestone for the language. There's something else that was happening. This was, again, the decade of object-oriented programming. Everybody was object-oriented programming. But there was one guy who is not interested in object-oriented programming. He had this kind of different idea, this generic programming, this idea that maybe we could focus on algorithms and write algorithms, implement them once, and maybe make them generically reusable. And so he was working on a library that was based on templates that implemented this kind of approach. And the gentleman on your right is Andrew Koenig. He was the chair of the library subcommittee of the standards committee. And because they had both worked at Bell Labs, they knew each other. And so he asked Alex, he said, are you going to submit your library to the standards committee as a potential library in the standard? And Alex said, well, the standards committee is pretty far along. They're going to want to release the standard pretty soon. And this library is a very, very large chunk of library. And it's also very different from anything that they've seen. So again, I'm going to pull the age card here, but I was programming in C++ before the STL was even submitted to the library. I know what container libraries looked like before the STL. You new kids today, you think vector just grew on trees. It was just obvious. I can tell you, I was a contractor, and I would go from project to project. I'd work, 9 months or a year on a project, then I'd go and look at another project. And I had to completely relearn the entire framework, including all the containers. And when I heard that this library had been submitted to the standards committee, and that it was this container library, and it was going to be a standard, I said, wow, this is great. I can learn how to use one library that will always be available to me. That's so cool. I can't tell you how unusual this container library was compared to all the other container libraries. And as I said, I had learned a lot, right? Because I went from framework to framework, right? This library, it didn't even have a containable base class. It didn't have an iterable base class for containers. I mean, how can you make this work? Fortunately, right? I was so confused, it didn't make sense to me, but I realized, you know what? It has the source. Okay. Actually, what happened was, I started to study, and I read that Alex's real interest was not containers. That was my interest because I had worked with all these other container classes. Alex's interest was algorithms. So I said, well, that's probably what I'll look at the algorithms, and that'll unlock the whole framework. It'll all make sense then when I look at the algorithms. And what do they have? Well, there's sort. Well, that's pretty useful, right? Have a nice efficient sort algorithm. And let's see what else is there. Well, there's find. Find doesn't really feel that special, right? I mean, haven't we all written find about, 20 or 30 times? And that was when I was thinking about it. I was like, really, yeah, we've all written find about 20 or 30 times. Maybe he's onto something here. Anyway, so yeah, it was not accepted in its entirety. It was the library, they threw out things we didn't really need, like hash and stuff like that. But they did, in fact, accept the proposal into the standard library. Then when the standard actually came out in 1998, this man had taken over from Andrew as the chair of the library group. And this is Beeman Dawes. And Beeman understood the mandate of the standards committee is to standardize existing practice. Now, they violated that with the STL. The STL was really an experimental library. When I say that nobody was doing containers like that, nobody was doing containers like that. Nobody was using that. That was an experimental library that people were using internally at Alex's company, but that was it. And the library group really kind of stuck its neck out to do that. But the problem that Beeman had is he said, if you look, there are no libraries out there that are in wide use that are not proprietary. And of course, if it's a proprietary library, we can't standardize it, right? So what are we going to do? Well, he worked with some other people on the standards committee, and he said, what we need to do is we need to encourage the development of freely available but high quality libraries. So he worked with Dave Abrahams and a few other people and started the Boost library. And the reason for the Boost library, the reason it was originally created, it was created by people on the standards committee, it was to create libraries that would be candidates for standardization. And if you look at the history of standard libraries since 1998, when it was created, and you look at the TR1, which became the fundamental contributions to C++11, you have to say that Boost has been incredibly successful in terms of library submissions to the standard, and also because there's over 140 or 150 libraries in Boost, it has been very, very successful. So, what do we have? We have now an international standard. We have the most innovative container library that's ever been developed. We have Boost, which is now a platform for creating high-quality, peer-reviewed, freely available libraries. It looks like C++ is ready to just take off, it's ready to explode until we get to the 2000s. And what went wrong? What was the fly in the... Oh, yeah, this thing. Because, I mean, why wouldn't you want this? This supports object-oriented programming, which is, as we say, going to solve all our problems. It's the language of the web, whatever that means. Oh, that means it's the language of the future, right? It's almost as fast, right? It's easier to learn and teach. Pointers are hard, right? So this really catches on. In the 2000s, if you can wind your brain back to that, you remember we had these desktop machines that Intel was putting such fast processors in that we had to kind of have operating systems with a lot of gratuitous animations just to soak up some of the power, right? And so if we have finally conquered performance, right? All through the history of computing, we were always fighting performance, and that's why we had to use languages like C and C++, which were kind of hard to use, but gave us performance. But now, we have conquered performance. We don't need to worry about performance again. We've conquered it. So now we'll use an easier-to-use language, right? Why would you want this C++ thing? You have to deal with with this baggage from C. There's a lot of complexity, like with templates and this whole generic programming thing, which, I'm not really sure that's going to catch on. You have operator overloads. I mean, how confusing is that? And then the whole pointers, you can just imagine there's some, university somewhere where some professor's calling another professor and saying, the intro to computer science class? Yeah. He says, we teach C++? Yeah. He says, if we taught Java, we could skip pointers. And he says, oh, that's right. Chapter 6 would just be gone. Okay. So this was the idea, was managed languages. And we have a couple of different choices now with managed languages because Microsoft wanted to get in the game. So we have the Java family and we have the Microsoft family. And it turned out that the colleges found out this was easier to learn. And so now things are starting to go great. And there's something else happened here, and that is when the C++ standard was released in 1998, the standard was released. We finally published the standard. Now have generic programming, the STL is part of the language. We've added a bunch of new other stuff to the language, a lot of stuff that wasn't existing. It's now standardized, things like namespaces, a bunch of stuff. And what happened to the standards committee when the standard came out? It got smaller. Why did it get smaller? Well, the reason is because the state of the art in 1998 was that the implementations, the compilers, and the libraries were many, many years behind the standard. And it was widely understood that even though the standard came out in 1998, it would be 4 or 5 years before there would be implementations that fully implemented it. That's a little hard for us to understand because we're spoiled as heck, right? But that was what happened. So in 1998, we ship a standard. Now, we're on the standards committee. Are we going to get together and start talking about the next set of features? Well, we haven't implemented the existing set, and we have no feedback from users about how well it's working, what they like, what they don't like. So in fact, the committee didn't. The first thing the committee said was, well, we're going to have to wait until we get some better feedback. So the first thing we're going to focus on is just fixing any questions or issues. We're going to debug the standard. And they did that for years. And given that, nobody really wanted to be on the committee. Attendance dried off, right? And it took a long time to get another standard out. In fact, in the entire 2000s, we know, there was almost nothing from the committee. Yes, there was a minor release in 2003, and there was the TR1, but almost nothing from the committee during that time. And we'll see, they weren't wasting their time, but nothing came out. And so you would think, with all the things with Java, with all the other things, that it was, C++ is going to become the next COBOL, right? It's going to become the legacy language. But that's not what happened. Starting about 2010, 2011, C++ roars back. The beast is back. And we're going to talk about why. Why is C++ back? Well, one of the reasons is that it turns out that we didn't solve the performance problem by just making really, really fast desktops. Because it turns out, now that we've done that, we realize the only people who care about desktops are the people in this room, right? Everybody else, what is a computer to everybody else? This is a computer, right? This is a computer. And so it turns out I care about how long my battery lasts. I don't care if it's written in Java or C++. I don't care about that, but I care about performance. I care about how long the battery lasts, right? And it turns out that the other thing that's important now, because this is just connected to the cloud's important, right? And again, it's all about performance. Now here, it's not battery, because I kind of suspect that thing doesn't run on a battery. But now I am concerned still about performance. It's just I care a little bit for different reasons. I care about the cost of the hardware itself. I care about the power cost to run the hardware. I care about the power cost to cool the hardware, right? So there's a guy named James Hamilton who works for Amazon, works for AWS. And he did this study where he looked at the cost of a modern high-scale data center. Now, I want you to understand, these are very, very carefully chosen words when we say modern high-scale data center. The key word there is modern, in that this is a data center that might be running for Amazon or Netflix or Google, meaning it's the same code on machine after machine after machine. It's the same code, but it's running on thousands of machines. And you'll see why that's important. But he said, these are the costs. And this is in decreasing cost. The top cost is the hardware, is the servers, right? And then power distribution and cooling. In fact, power distribution and cooling is more expensive than the actual power. It's costing us more to cool the machine than it is to power the machine. And of course, the networking equipment and other infrastructure. The interesting thing here is that the top 3 costs are directly related to software performance. In fact, if you can make your software run 10% faster, you're going to make your costs go to 91%. You're going to capture almost all of your performance on the bottom line. Almost everything. Because it is so related to performance. So where are the programmers, the IT professionals? Did he forget them? Are we not going to pay them? Is that the new plan? They're all going to be in India? Right? We're not going to pay them? No. They're there, right? But remember, it's one set of software running on thousands of machines, right? By the time you put that out, the cost of developing the software is in the noise. These data centers are very expensive. Very expensive. And performance is really, really important, right? And it turns out that if you decided to select a language that made it easier for programmers to write code, you're optimizing the wrong thing. You're optimizing the wrong thing. It's all about performance. Something else, of course, happened in 2011, and that is we got a new language, at least. Feels like a new language, right? In terms of page count, the standard almost doubled, not quite. Now, what is the most important feature in C++? What is it that C++ needs more than anything else? Less complexity. But unfortunately, because we also care about backward compatibility, we can't go in and hack out the complexity, right? We're in this weird situation, or I should say the Standards Committee is in this weird situation where we have to simplify the language, and the only thing you can do it is add more to it. But they actually did. They figured that out. Look, auto simplifies the language, right? Range-based for loops simplifies the language. I don't even want to talk about that one. Enums are more consistent, right? When I'm teaching people about, if something's inside braces, you want to say colon, colon, right? These things, universal initialization. Now, I know I'm initializing 2 braces. I teach this. 2 braces, I'm initializing something. That's what that means. They added things due to backward compatibility. Yes, everything has to work the way it always did, but we can add things to make things less complex. But of course, that's not all they did. The other thing they did was they tried to make the language more modern. What do we expect of modern languages? Well, we expect lambdas, right? We expect support for Unicode characters. We expect tuples. We expect smart pointers. These are the things that we need in modern languages. And then, because it's C++, we also did things that no other language is doing, right? Like all sorts of things for better support for library authors, move semantics, those kinds of things. And of course, we finally have multi-threading, because of course we were never able to do multi-threading before C++ 11, right? This has turned out to be really popular. This is a bit dated. It's from Stack Overflow in 2015. But it's the list of most loved languages. Look at this. These are all these new, brand new, shiny languages except C++ 11. Except C++ 11 is also a brand new, shiny language. And it's seen that way by the people who are using it. If you've been using classic C++ and you get to use C++ 11, you're going to feel like, wow, I love this language, right? At least the people on Stack Overflow did. There's something else, too. What is this guy? Clang. That's right. So I'm going to count this as something since 2010. This is the date I'm saying that the language roars back. But actually, LLVM and Clang have actually been much longer than that. It's just that it wasn't interesting to C++ people until about 2010, 2011, because we couldn't compile C++, right? We were able to compile C and Objective-C, and I think those are programming languages. But we couldn't compile C++ until about 2010, and suddenly we started to have a language and a new compiler. Now, did we not have a compiler before? Yeah, we had compilers. But what was special about this? Well, it just gave us some competition, particularly in the area of error messages. Sometime pull up a C++ compiler from 2010, not Clang, one of the competitions, and look at the kind of error messages you get and compare them not to Clang, but to the error messages on the same thing today, right? This competition changed all the other compilers. It changed what we expected of error messages. And build performance. Runtime performance, Clang still has some issues, but build performance was again kind of a shot to the competition. But I don't think in the history of C++ people are going to think about those things. I think the important thing about Clang is this. This is a toolkit. If you think about Clang as a compiler, you're missing the point. Clang is really a set of tools. Actually, LLVM and Clang are a set of tools. And you can build a compiler out of them, but you can build all sorts of other things. You can create new features, you can build analyzers, you can build translators, all sorts of tools. And this is going to make it, already has, made it a really important thing about increasing our ideas about code, creating new tools, all sorts of things. Another thing that's been very important is that open source is very, very friendly to C++. If the compiler can see the source, it can do more and better than if the compiler only sees a library. Right? This is from GitHub. It shows popularity of languages. Of course, C++ is not usually the language you pick for GitHub projects. GitHub projects tend to be web things, open source things. C++ is not necessarily its power. But you'll notice that it has, in fact, grown in this time frame. Something else happened. Remember, what happened to the Standards Committee when 98 shipped? What happened? It shrunk. What happened to it when 2011 shipped? It exploded. Why did it explode? Well, remember, why did it shrink? The reason it shrank was because they knew they were going to have to wait 5 years to see it implemented. When the standard shipped in 2011, there were already two tools that were breathing down its neck. And within a year, we can quibble a little bit about how fully they implemented it. But we'll say, for all intents and purposes, within a year, we had an implementation. By 2012, we had an implementation of C++ 11, right? And this has only accelerated. We will have complete implementations of C++ 17 before there actually is a C++ 17. That's where we're at today. And that made a huge difference, because what happened is people who went to the Standards Committee with a possible idea for a library or a new feature, and it used to be when they said, wait, it takes 13 years to get a new standard out? And after that, it takes another 4 or 5 years maybe to get it. No, it's not like that anymore. Now, you go to the Standards Committee and you propose something and it gets put into the working draft, and Richard Smith goes home and starts implementing it right away in Clang. The GCC guys are doing the same thing. And the Microsoft guys, who still have some work to do, but they're doing the same thing. They're all aggressively going after the standard as soon as the ink dries, or before the ink dries, if you will. And so what we've seen is that all of these, now some of these study groups have actually, they no longer meet. They've actually finished with their meeting. But the point is that the committee paralyzed its effort, right? It said, we have all these new people interested in the standardization process because the response is so quick. We can actually propose something to the standard, and maybe even before the standard ships, we get real users trying it out. That is really cool. So that inspired a lot of people, and that's why the Standards Committee has become much larger and much more active. So about 2010 is when the Standard C++ Foundation was formed. How many of you go to isocpp.org? Excellent, excellent. And of course, I'm a very, very big fan of the Standard C++ because they run CPPCon, which is an important conference for me, so I love that. Something else has happened, and that is that there was a new IDE. I didn't put this slide in here because the new IDE, it's great, it's evidence that things are going on in the C++ world, but that's not why it's here. The reason it's here is because I'm going to introduce some information. When this new IDE came out, before it came out, JetBrains did a lot of market research. And they actually, after the IDE was released, Anastasia, who's at the JetBrains booth, you can go by and say hi, she's very nice, she released the market research that she had done before they decided to publish C-Line. And I asked her, I said, would you mind if I shared your infographic of the information that you released, and she said, okay, but be sure you tell people what the sources are. And she's not saying that to say what a great job of research she did. What she's saying is, this may be the best research available. That doesn't mean it's good. There's a difference between best and good. You know, this is based on job wanted ads, right? There's a lot of guessing in this. So with that caveat, let's look at the information that she got. The first thing that surprised me, because I remember Bjarne used to say there's about 3 million C++ programmers, but they figured there's almost 4.5 million C++ developers. That was a surprise to me. It wasn't really a surprise to me that there was more C++ programmers than Python programmers. What actually surprised me is how close it was, but that's a different matter. This one also surprised me a lot, and that's because, you know, I'm an American, I work in Silicon Valley, I think the entire world is right there, right? This was kind of a surprise. It's like, wait a minute, there are more C++ programmers in Europe than there are in America? What? There's almost half as many C++ programmers in South America as there is in America? Really? And look at that number in Asia. Asia Pacific. What? Another 1.5 million programmers? Where? I don't know these people. But I'm here to start. Hi, I'm Jon. This is also where C++ is relatively ahead. I don't really know what that means, so we'll skip that one. This was also not really a surprise. Finance, banking, games. I knew about this. What I was kind of surprised about is how much concentration there was in finance, but maybe that's just that the finance people run a lot more ads than everybody else does. I don't know. This is just kind of for curiosity. These are the words that appear in C++ wanted ads. These are the other things they mention. So, oh my, that's just depressing. This probably wasn't much of a surprise either. This is kind of broken down by platform. I thought this was a little bit interesting. It breaks down development, and I think, I'm not really sure what ANSI is. I think ANSI just may mean ANSI C, but there we go. Anyway, now this, of course, this information was before C-Lion is out, so it's a little bit dated, but still, we're seeing really good penetration of C++ 11, I thought. I was, very happy about that. Something else that's happened since 2011, how many of you are familiar with CPP-Cast? Right? How many of you have a commute home that's going to be an hour or longer? Right? I think there's at least one episode of CPP-Cast in your future. Other things that you'll see, Reddit, again, this is a little bit dated, 2015. They hit 30,000 subscribers. This is the CPP subreddit. Very, very active, lots of people there. Stack Overflow, again, this is a little bit dated, but you can see the number of questions and posted on Stack Overflow. CPP reference, I think there was a discussion of that this morning as well. I'm a big, big fan of CPP reference. And then C programming, another community, another online place where you can get answers. And then, and this is again something that's near and dear to my heart, all of these conferences are post-2010. All of these conferences happened since the beast came back, right? You guys, I mentioned earlier CPPCon. You might know of that one. Going native is not going to happen again, but it was Microsoft, again, trying to attract attention to the fact that C++ was very interesting in trying to get app developers on their platform to write more performant apps. C++ Now is a rename of a conference that existed before, but again, focusing on C++. And then there's another conference that's interesting to C++ developers, and that's the ADC conference, which just happened in England. So I hope you understand why I feel like the beast is back. I think that we had kind of, the 2000s was not a great time for C++, but I think we're on a roll. I think there's a lot of interest in C++. I think the fact that there's 600 people at this conference is evidence of that. I'm not sure how we're doing on time here, but I'm happy to take any questions. And I have a very limited number of books if someone wants a signed book. Any questions? Oh, thank you.
First of all, excellent talk.
Thank
I
you.
just wanted to make a comment. One of the reasons why C++ is not really that prevalent on GitHub is that the largest C++ projects, free software projects, are not developed on GitHub. And they're generally Euro-based. For example, LibreOffice KDE and Mozilla is worldwide, and nobody uses GitHub.
Uh-huh. Okay. All right. Yes. Oh, wait, hang on. Let him.
So actually, it's just a bit of information. I came from South America, and we are in the 5th year in a row doing C++ conference in South America. So I am into the committee of this conference, and the biggest one was around 150 people, but the biggest conference that we did in South America based on C++ was around 150 people. But next year it will be the 6th year in a row that we are doing it.
Can you send me information about that? This is all
Sure.
news to me.
Yep.
And I thought I kind of knew what was going on in the community. Absolutely. You have my email address?
Not yet.
It's jon@cppcon.org.
Okay.
From all the time, always I was very happy that, and I still believe in the revolution, the new revolution of the C++, as Herb Sutter had said, Renaissance, C++ Renaissance. But I was quite surprised that, for instance, in Visual Studio 2015, for instance, the C++ is not coming by default in their setup. So they are deploying C# on Visual Basic, but they are not deploying. You have to make a custom installation.
Yes. And
So I'm still wondering, are they really serious in terms of C++ Renaissance? It's a bit, I don't want to lie myself, the less for me.
what I would say is that actually they were prepared to do that. They were all set to do that. But James McNellis, who's at the conference,
Yes,
he said, let's not do that. So go have a conversation. No.
I will, probably.
I can hide behind the fact that I'm a Microsoft MVP, and so I've signed a non-disclosure. But that's really just trying to distract you from the fact that I have no clue what was going on in there. I can't tell you what's going on there.
No.
I mean, I'm certain that there were lots of factors. I don't know. I do know from what I've seen, from what I observe, and I think clearly anybody who's been following this closely is Microsoft's making an incredible investment in C++.
Indeed.
They're taking it very seriously. Is it as much as we would like it to be? They still are shipping that other thing, and you know.
I'm a Visual C++ developer, mainly.
What's that?
I'm in general a Visual C++ developer, and I see not the same effort in C++ less in terms of Windows libraries as it happens for .NET, comparing to MFC that is basically not evolving anymore. So the reason I asked about that and I pointed about this part is that I don't want ourselves to lie a bit that the future looks very, very bright when it seems that some others are not seeing, and they are the vector of our future.
I don't know exactly what to tell you. I think that Microsoft has made a significant investment in C++. I know I attended I showed you the conferences that Microsoft did, the Going Native conference. I was fortunate to attend those. There were only 2 of them. And because I do conferences, of course I pay attention to these kinds of things. You know, I'm well aware about how nice this conference is, and what features there are. You know, I went to that conference. That conference, I think it was $125 for a 2-day conference. Now think about that. It included a party, it included lunch, and on top of that, they streamed all of the content. They didn't just record it and make it available, they streamed it all. I will say that when we talked for CPPCon, and the difference, of course, is that some people think that CPPCon is somehow a follow-on to going native. And I understand why people would think that. It's in the same location, and it was a year later. It made sense. But the truth is, we don't have any of that Microsoft money that they streamed, right? But I did talk to, when we decided we're going to video and record and put all of our content online, we talked to the video guys, and we said, look, we're thinking about maybe streaming the keynotes. And what would that cost? And the video guys said, okay, listen, we know how to do that. We just had a Linux conference. We did it for them. If you want to stream it, no problem. We can do that. We can take the money from you and stream it. But there's two things you should know. One is it's really, really expensive. The Linux conference, we did that. He said there were times when there were only 8 people online watching this very, very expensive live feed. He said it would have cost less to fly those 8 people into the conference than it would have to do the streaming. So I'm really, really aware that Microsoft put an awful lot of money into C++ for that conference. And I can't tell you on every single, what decisions are made. I don't know. All I am looking at is the big picture there. I'm not a Microsoft developer, so I really don't know these things. And I don't think I'm trying to paint an overly rosy picture. I think you could get up here and you could say why Rust is a wonderful language or why Go is a wonderful language and paint a rosy picture for them too. There are going to be setbacks. There are a lot of problems, if we wanted to talk about problems in the community. There are a lot of issues we have to solve to get forward. So it's not like, my point was in talking about the state of where we're at is to be optimistic because I think the trend has changed so much from 10 years ago. And that's the point I'm trying to make. Any other questions?
Hello. Just one comment, maybe one possible answer regarding the why MFC is dead. You should not forget that Qt killed MFC, and Qt is very popular today in C++. And each year here you have hundreds of people who come for a conference in Berlin. So thank you for this fantastic show about the history of C++. And so it triggers me. I'm a curious-minded guy, so I'm curious. How, before internet, did you manage to get up to date in C++ and know what was going on?
What made you think we were up to date on C++? I can remember when I was reading Scott Meyer's book, or books, and one of the questions I had is, where did he get this information? Because most of the things he was talking about wouldn't compile on my system. And so, this was in this period of time before the standard was really well implemented, and yet Scott was already talking about standard behavior and things like that. And, now anyone can get the mailings. At the time, that was not easy to do. You really had to be on the committee in order to get what was, at the time, and I think still called the reflector, which is essentially a mailing list, right? But now you can go to isocpp.org and Jens will give you summaries of the papers and all sorts of stuff. It's much more available than it used to be. And in fact, if you're really inclined to do this, you can read the papers and know what's coming even before it gets in the standard. And then you read the trip reports and you see what got voted on, all that stuff. So there's a couple things. One is it was much harder, absolutely, but also the committee was moving much slower. Right? There's a lot more people in the committee, a lot more stuff is happening. We're a lot more ambitious what the committee is willing to take on than they used to be. So.
Hi, thank you for the talk. I just want to defend Microsoft a bit here as a user.
Thank you.
Because I think they are doing great strides, great progress. Like Visual Studio is better than ever. They are rewriting their compiler. Through this, they started quite badly. We all remember Visual Studio 6, right? But they are rewriting the stuff. There's now it's Visual Studio 2017, and yeah, I guess they're gonna address the installer experience. I guess why it's not there by default? That's a good question. It should be like a greater push worldwide. I don't know for C++ to get a better name out there. So, but they're making good progress in my eyes.
Okay. Anybody else have wonderful, favorable feelings for Microsoft? Show of hands. Okay, I have a favor to ask you, right? Don't talk to James McNellis. Those of you who hate Microsoft, go find James and talk to him first. I know that dinner is going on, and I don't want to hold anybody. I will stay and talk about C++ until, until December. But I don't want to hold anybody if you feel like you want to leave. Like I say, I've got a small number of books, and if you're the first person up here, then you get the book, right? Thank you.